Alright, so today we're going to take some notes on atmospheric science. And the first topic that we are going to start off with is solar radiation and energy. Ignore my dog running through the house. Alright, so for this part, we are going to draw an Earth. You can draw your little countries on it if you want. Alright, so let's back. So typically, if your Earth is straight up, this is where your line would be. But we know that our Earth is actually tilted, so it sits on a tilted axis, and the tilt from straight up to where it is 23.5 degrees. Okay? And then in the center of the Earth, when we're talking about latitude, the equator, actually, I drew this pretty bad because you know the equator goes through South America. Just ignore my little countries there, they're pretty bad. So your equator is at 0 degrees. Above the equator at 23.5 degrees north is what we call the Tropic of Cancer. We said that that is 23.5 degrees north. And then 23.5 degrees below is what we call the Tropic of Capricorn. So it's 23.5 degrees south. Alright, so along the equator, we call this our tropical region. Temperatures stay warm year-round. It's always tropical weather. And then above, up here, we call this our temperate region. And below is also a temperate region. And then down here, where it is always cold, it is our polar region, and this is obviously Antarctica. And then up here we also have polar region. Arctic. Alright, so up here is where we are at 90 degrees north latitude, and down here is 90 degrees south latitude. Okay. So obviously we know the equator is 0 degrees latitude. And when you go north of the equator, we call this the northern hemisphere. So anything north of this equator is considered the northern hemisphere. Anything south of the equator is the southern hemisphere. So anything south of the equator here is the southern hemisphere. So just to kind of get your geography in your brain set up to thinking about where things are and how we're going to reference to different points, I wanted you to draw this out so we could talk about it and you could see what we are discussing. So make sure you have your earth tilted. And then we're going to come down and we are going to discuss how the seasons work and what actually causes seasons. So down here, we're going to start a new section on seasons. Make sure you can still see. Okay. So our planet obviously revolves around the sun. So on this one, I'm going to start using some colors so that you can see exactly what I'm talking about. So I'm drawing our sun orange. Okay. And then I'm going to have another earth up here. One down here. One over here. And one over here. Okay. So we know our Earth is still tilted on its axis. So as we go around, this is the direction we're going. Alright, so I'm not going to color in our Earths yet because I want to talk a little bit first. So we know that seasons of the Earth are created from the tilt on its axis and the rotation around the sun every 365.342 days. So the rotation around the sun is not actually 365, it is a little longer. And the dates that we're going to use on this diagram are based on the northern hemisphere. So every date that I say one of these events is happening, we're basing on what the weather is in the northern hemisphere and not in the southern. So dates on this diagram are based on the northern hemisphere. And so like I said, the dates and the seasons that we're experiencing in this diagram are going to be based on the northern. So if you were thinking about the southern hemisphere will always be in opposite seasons. Alright, so we're going to start at the top. And this one we're going to say is our autumn equinox. And now we're going to pop over here and we're going to kind of define what an equinox is because I'm not sure if everyone knows. So that is when day and night are equal in length. So that means 12 hours of daylight, 12 hours of nighttime. And this happens when the sun is exactly in line with the equator. So the autumn equinox for the northern hemisphere happens on September 21st. And so on this one we are going to leave our Earth as colored with a little darker area to the side. So I'm going to draw some little countries. And we are going to be mostly blue in the water, a lighter blue. This area over here, I'm going to make the blue a little darker because we've got a little darker area back here. Okay, so if we started in autumn, obviously the next season that we're going to see is going to be winter. So for the northern hemisphere, the winter solstice is December 21st, and this is when you have the shortest amount of daylight hours. Okay, so if you're talking about the Arctic, so up here, well, you can't see on my paper, but the Arctic is going to actually experience 24 hours of night, and Antarctica is going to have 24 hours of daylight. So remember, Antarctic is at the lower part of Earth, Arctic is the higher part. So during the winter solstice, it is 24 hours of night up here, and then it is 24 hours of dark down here. So for this one, I'm gonna have my little countries. My blue for water. And I'm actually gonna do this a little different. So even up here where I did this little side, that's not gonna work either. Find a dark enough color. Okay. So where I did this dark blue over here, this time I'm going to have a whole half of the Earth being dark. Because this half of the Earth is completely away from the sun, it is dark. Okay? And then moving down here is going to be our vernal equinox. And obviously, if this up here was the autumn, this would be considered the spring, but they call it vernal. But this is March 21st. And so we're going to have countries, water, and we're gonna color all of this dark over the top. Because at this one, this is if we are looking at our solar system straight on from here. So if you were standing here and you were looking, the reason that this is dark is because this is what is facing you. This is what is away from the sun. This half of this Earth is dark because if you were standing here looking straight on at it, this half would be dark. Same over here. Okay? And then after spring comes summer. So this is our summer solstice. And it is on June 21st. It is the longest daylight hours. So we have 24 hours of day in the Arctic. And we have 24 hours of night in Antarctic. Okay, so again, our little countries. Some light blue. And then this half is going to be dark. Because remember, if we're standing here, we're looking straight at the earth to the sun, this half is going to be dark. Okay, this should all really be pretty light. I mean, you're gonna have a shadow right here if you were looking, but not much. So this should all be pretty light. You don't have to worry about coloring this side dark. Okay. And that is going to cover our notes on the seasons. So we know that the seasons happen because of the tilt of the earth and the rotation that's going on. And now you have dates for each one of these seasons. You have your basic geography of your latitudes, where these lines are that we're going to use to reference later on.